Welcome to my Advanced Database Management System course. In this section, we discuss about scaling and high availability, vertical scaling, horizontal scaling, load balancing, replication, clustering. Let's enjoy. Scaling and high availability are critical considerations in database management, especially for applications with growing user bases, increasing workloads, and demanding performance requirements. Here are some best practices for scaling and achieving high availability in database management. 1. Vertical scaling. Vertical scaling involves adding more resources, CPU, memory, storage to a single server to handle increased workload. Upgrade hardware components or provision larger instances to support growing database requirements. While vertical scaling can provide immediate performance improvements, it may have limitations in terms of scalability and cost effectiveness. 2. Horizontal scaling. Horizontal scaling involves distributing database load across multiple servers or instances to handle increased traffic and workload. Implement sharding, partitioning, or replication techniques to distribute data and transactions across multiple nodes. Horizontal scaling offers better scalability and fault tolerance, but requires careful planning and coordination. Use load balancing techniques to evenly distribute incoming traffic and workload across multiple database servers or replicas. Implement load balancers, reverse proxies, or application-level load balancing to optimize resource utilization and improve system performance. Replication. Implement database replication to create copies, replicas, of the database on multiple servers. Use synchronous or asynchronous replication to replicate data changes from the primary database to replica databases. Replication improves fault tolerance, data availability, and read scalability. 5. Clustering. Deploy database clusters or cluster management solutions to create a group of interconnected database nodes that work together to provide high availability and scalability. Use clustering technologies such as MySQL cluster, PostgreSQL cluster, or Oracle RAC, real application clusters, to achieve fault tolerance and load distribution. 6. Data partitioning, sharding. Partition large datasets into smaller subsets, shards, based on predefined criteria such as key ranges, geographic regions, or user demographics. Distribute data shards across multiple database nodes to achieve horizontal scalability and improve query performance. 7. Replication lag monitoring. Monitor replication lag between primary and replica databases to ensure data consistency and minimize replication delays. Implement monitoring tools and alerting mechanisms to detect and troubleshoot replication lag issues in real time. 8. Disaster recovery, DR. Implement disaster recovery, DR strategies and solutions to ensure business continuity and data resilience in the event of hardware failures, natural disasters, or human errors. Establish off-site backups, data replication, and failover procedures to minimize downtime and data loss. 9. Automated failover. Configure automated failover mechanisms to detect database failures and automatically switch traffic to standby nodes or replicas. Implement health checks, heartbeat monitoring, and automated failover scripts to ensure fast and seamless failover in case of node or server failures. 10. Multi-region deployment. Deploy database instances across multiple geographic regions or availability zones to improve fault tolerance, disaster recovery, and data locality. Use cloud-based database services that offer multi-region deployment options for improved high availability and scalability. 11. Performance testing and optimization. Conduct performance testing and optimization exercises to identify performance bottlenecks, scalability limits, and optimization opportunities. Test database scalability under simulated production workloads and adjust configurations, indexes, and queries for optimal performance. 12. Regular maintenance and monitoring. Perform regular maintenance tasks such as database backups, software updates, and performance tuning to ensure the health and reliability of the database infrastructure. Monitor database performance metrics, replication status, and cluster health to proactively detect and resolve issues. By following these best practices for scaling and achieving high availability in database management, organizations can ensure that their database systems can accommodate growing workloads, maintain data availability, and meet performance objectives even under demanding conditions. Continuous monitoring, testing, and optimization are essential for maintaining the scalability, reliability, and performance of the database infrastructure over time. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson.